In our last session, we had looked at how to implement a stack data structure using a linked list, using an array list, and then we also looked at a vector implementation of such a stack data structure, and we also performed some experiments to validate the performance of those individual implementation. So today we will look at a new data structure in Q, where a queue data structure follows the first in, first out principle. And it would be pretty similar to what we did with the stack, except that we have a different process that we need to follow to add and remove elements from the queue. So every time we are adding an element from a queue, we call that as an enqueue process, where we are adding an element, let us say the element O, into the queue. And every time you're adding something, we are adding it towards the end of the list, right? We are adding it like a typical line in a grocery store. A new person would come in and be added to the line towards the end of that line, right? So similar to that, an NQ would happen where we are adding something at the end of the list. And a DQ is where we are removing something from the front of the list, right? So we are removing something from a front of a list, so we need to maintain a pointer in front, right? Um, if we would compare this process, the queue process with the stack that we had learned in our last lesson, so we have a stack where the elements were pushed in into the stack at the top of the stack, and then the elements were popped out from the top of the stack as well, right? So we maintained a pointer in top, and we were saying that we will update the top every time we were adding a new element. We were updating the top, and we were either removing an element from the top, or if we were able to do a push operation, then we were pushing stuff to the top as well. So basically we are removing and adding at the same position, whereas in a queue it's a different position, right? So one position is for the NQ, and the other position is for the DQ, right? So DQ would be at the front of the list, and NQ would be done at the end of the list. So with this understanding, we will also look at the implementation of a queue data structure, and at that point we will take up an activity to practice such a queue data structure as well, right? So this QADT, as we call it in an abstract data type, because it has all the necessary methods inside the data structure. So we also have a similar method like stack called the peek. So peek at any point of time would simply return the front element in the line. So it will not remove the element. It will simply return the front element. And size will simply return the size of the list here. At any point of time, we can get the size of the list using this queue data structure. So at this point, we will shift our focus to the implementation. We will look at the review of the code, and then we will take up an activity based on that. Okay.